Hello, welcome back. In this video we'll discuss the magnetostriction. The magnetostriction is seen in ferromagnetic materials when they are placed in an external magnetic field. The applied magnetic field will cause certain changes in the dimensions of the magnetic material. The magnetostriction was discovered by James Prescott Joule. The magnetostriction is a property of ferromagnetic materials which cause them to expand or contract in response to a magnetic field. What this effect does is, this effect converts the magnetic energy into mechanical energy. So it converts magnetic energy into mechanical energy. And the expansion or contraction can be seen as long as the external magnetic field is applied. The moment the external magnetic field is removed, the material goes back to its original dimensions. Essentially, magnetostriction is a property of ferromagnetic materials that causes them to expand or contract in response to an applied field. And this is a reversible process. Meaning, the moment you withdraw the applied external magnetic field, the material will get back to its initial original size. We have seen the ferromagnetic domains in a ferromagnetic material. Suppose we have the domains in this fashion in a specimen of a ferromagnetic material when the external magnetic field intensity H is 0. When H is 0, we have this type of random arrangement of the ferromagnetic domains in the material. The moment you apply the external magnetic field in this direction, that is from left to right, then these domains, they orient themselves in the field direction. As a result, the length of the specimen is going to change slightly, or the material will be expanded. Magnetostrictive materials can expand or contract in response to the applied external magnetic field. Suppose if the material expands, then you call it as positive magnetostriction. On the contrary, in response to the applied magnetic field, if the specimen contracts, then you call it as negative magnetostriction. The humming sound from a transformer is essentially due to the magnetostriction. The magnetostriction is defined in this fashion. The magnetically induced reversible elastic strain, that is delta L upon L, where L is length of the specimen and delta L is the changes in the length of the specimen, is called magnetostriction. And it is caused, as we have seen, due to the rotation of the domains. It is caused by the rotation of domains. What domains? The magnetic domains. The rotation of magnetic domains give rise to internal strains in the material, causing its contraction or expansion. The magnitude of magnetostriction for a given material depends on the initial orientation of the domains. Magnetostriction depends on the initial orientation of the domains. The ferromagnetic materials may show both positive and negative magnetostriction with different magnitudes according to the intensity of the magnetic field. Materials showing negative magnetostriction, they contract when they are exposed to external magnetic field. One interesting aspect about iron is iron shows positive magnetostriction in weak magnetic fields and negative magnetostriction in strong magnetic fields. This is one of the unique qualities of iron. Iron exhibits positive magnetostriction in weak magnetic fields and a negative magnetostriction in strong magnetic fields. The examples for magnetostrictive materials are iron, nickel, and cobalt. In this video, we have started our discussion with the discoverer of the magnetostriction, that is James Prescott Joule. We have said that The magnetostriction is a property of ferromagnetic materials that cause them to expand or contract in response to magnetic field. And essentially the magnetostriction converts the magnetic energy into mechanical energy, and it is a reversible process. There are two different types of magnetostrictions. One is positive magnetostriction. If the ferromagnetic material expands in response to the applied magnetic field intensity, then we call it as positive magnetostriction. On the contrary, if the magnetic material contracts in response to the magnetic field, then you call it as negative magnetostriction. Because of these contraction expansions of the magnetic materials, we hear a sound from the transformers, which is a humming sound. The sound is essentially due to the magnetostriction. Magnetostriction is defined in this fashion. The magnetically induced reversible elastic strain delta L by L is called magnetostriction, and it is caused by the rotation of the magnetic domains. The magnitude of magnetostriction depends on the initial orientation of the domains. Further, we have seen the case of iron, where iron shows positive magnetostriction in weak magnetic fields and a negative magnetostriction in strong magnetic fields. We have also seen the examples for magnetostrictive materials such as iron, nickel, and cobalt. Thank you.